Hi class, let's continue working on table 5 now. So it's calculating the marginal value. So we want to know, like, for an additional dollar and additional cash, one additional cash, how much is the marginal value of that. So to do that, so we want to figure out, for a financially constrained firm, how much is the marginal value of cash. So to do that, this is the code to do that. So the equation to get the marginal value of cash is this equation. So we want to use the coefficient of DC plus the mean of LC. LC is lag of cash, multiplied by the coefficient of this one, LC multiplied by DC, also plus the mean of liability, multiplied by the coefficient of L times DC. So see, we need to figure out how much is the mean of LC and mean of L. So we got it from the above equation here. So we run the regression of excess return on the variables if it's financially constrained firms. So let's run this, and then so we calculate sum of LC and then mean of LC. So this variable equals to this. So we get the mean of LC and plug into here, get the mean of L from this, and then plug into here, so we can get the VC for financial constrained firms, and then store the results. And let's try this. And we can see, here it is. So this is a regression. So first thing, we get the regression, and then we got the coefficient, and we use this coefficient result, and also we use the coefficient result and then use the mean and to get the VC here, but it's not reported in VC. So this is a marginal value of cash. MVC here, it's a marginal value of cash. Let's look at our data table here. So you see, so this is based on, we're only running regressions for FC firms. Okay, so next one is a program. It is a program here. So to run this program, so we should start from beginning and then to run the whole program together. So we will not see anything shown here because this is a program. The results are stored in the memory. So the program is called capture program. The program is called MVC here to find, because it's in the memory. So to find it, you can type program dir. You will find all the program that has been run, that we have been running so far in the memory. So you can type that, right? Let's see, program dir. So this is a program in the memory. The one on the top is MVC we just created. So you can, if you type MVC, run this program and see what we get. So you see, this is just for LC. This is the program results. LC and for L. the marginal value of cash is 1.62 for $1 of cash. Its marginal value of cash is 1.6 dollars. So to financially constrained firm. So you can run it. It will show the MVC here. So see, we just see the results. So it shows the marginal value of cash. It's still based on this equation here. So this is a mean of LC. This is a mean of L. Plug into the equation, and coefficient we got it from the regression results previously, and then so we can calculate the marginal. Here. So you see coefficient, we get it from here, so we can calculate the marginal value, and also we can do that for the unconstrained firms. Now we want to check the difference between the two groups. So we run regression for financial constrained firms and unconstrained firms, and repeat it for both. And this is you can type help as I think it's unrelated estimation something, and then you can check the help file to find it, help st. Yeah, so this is the command. So typical applications of SUASTIT are test for intra-model and cross-model hypothesis using t-test or test N1 here. So in our case, we're using this command, and we're using this test command to check the difference between, for the mean, the group is based on sites, for the mean between DC and between FC's DC and NFC's DC, and stored the return values into the memory. So this is, we're comparing the difference of the mean of DC between the two groups. So you see here is the results. So we're testing this hypothesis. So probability is not significant if we separate the firms by sites. And this is a program. If you click on Control and R, and it will run this program. Let's see. So it will run this program, but it's the result is in the memory. It's in the memory. So if you write this code, and then you can use it over and over for different variables. So the code part will be easier. For example, you want to, if you do this, so you will call that program. You will call that program. So you see the difference between LC and FC's LC and NFC's LC. This is a probability. So you can call this program with different variables. So it's just convenient. Okay, so now the next one is for sites. We are comparing. Also, we compare the firms based on sites. between the two groups. So we're trying just to get the results like this. So payout ratio, this is table 5. I was wrong. This PowerPoint doesn't have table 4. This is table 5. So between the two groups, based on payout ratio on firm size, so we're doing this now. And also rating, the ratings. So we are getting the results, and then we can do the dividend. This is related to payout ratio, and the same thing for dividend. And then we can, so since we don't have the bond rating and commercial rating results, so we're using the number of dividend paid and the total amount of dividend paid to check between the financially constrained and unconstrained firms, are there any differences. So we just run these regressions. Since we wrote the program, so we can call that program. So you see, this is test B program. So the following part is just calling this test B program and run this program with the new inputs here. So and the results would be in table 5. And you can check table 5. So table 5 should be similar to this. So it's this is the last table. All right. So this is a paper published in JF. This is a top journal in finance. So we just replicate the study using the Chinese data. So it doesn't seem to be very difficult to follow this paper, and you can probably do an empirical study like using the newer data and study like during the financial crisis, like what kind of marginal values of cash during the financial crisis, and this will be a good empirical study. And the code are just here. You can just throw in and use the US data from CompuStat, and it could be a pretty easy empirical study. Just following the code, the program here. Well, and that's all for this project empirical study. Well, thank you for watching.